Hi everyone. We're going to solve word problems by rational equations. These are where you have to translate word sentences into equations. So basically we have 1/5 of a number is 7 less than 2/3 of a number, and we have to find the number. So the first thing we're going to do is let n equal the number. And then just kind of read across. 1/5 of a number is 7 less than 2/3 of that same number. Okay? And then what we're going to do is solve for this and just multiply everything through by the LCD. The LCD in this case is 15. So I'm going to multiply each piece, or you can just do, distribute it by 15. 15, 15, and 15. So 5 goes into 15 3 times. 3 times 1 is 3. So we have 3n equals 3 goes into 15 5 times. 5 times 2 is 10n minus, this is over 1. So 15 times 7 is going to be 105. Then we solve for n. So basically I'm just going to add 105 to both sides. Subtract 3n from both sides. Do it all together, and we're going to get 7n equals 105, and n equals 15. And that's how you do that problem. You just have to translate. Okay, the next one is the sum of two numbers is 45, and their quotient is 35. So we're going to let the first number be n, and the second number we're going to let the second number is going to be 48 minus n. Do you see why we did that? Because if our first number is, say, 5, then my second number is going to be 48 minus 5, because we're talking about the sum. All right, and then I'm going to just read it across. The sum of two numbers, which would be n is 48 in their quotient. So the quotient of the first number over the second number is means equals 3 over 5. So I'm going to cross multiply, and I get 5n equals 3 times 48 minus n. So we get 5n equals 144 minus 3n. And we just solve. I'm going to add 2n to both sides, so I get 2n. No, it's going to be 8n. We're adding 3n. Equals 144. All right? So n is 18. That's your first number. Your second number is 48 minus the first number, which equals 30. So our second number equals 30. This equals 30. Okay? The next problem is 1/6 of a number is 3/4 less than 3/4 of the number. It's like the first one we did. So we're going to just let n be our number and just read across. 1/6 of a number is 7 less than 3/4 of the number. My common denominator is 12. So your least common denominator is 12. And just multiply each piece by 12. So we get, this is going to be 2n equals That's going to be 3 times 3 is 9n minus 84. All right, and then you solve. So what I'm going to do is, like before, I'm going to add 84 to both sides. Put it over here. And I'm going to subtract 2n from both sides. Take care of that. We get 7n equals 84. So n equals 12. All right. The next one, it's very similar. So we're going to let n equal the number, and I'm just going to start writing here. 3/4 of a number n is 7 more than 1/6 of that number. My LCD is 12. Is this the same one? No, that's less than. So we're going to multiply each piece by 12. And go pretty quickly here. So we have 4 goes into 12 3 times, so that's 9n. 6 goes into 12 2 times, so that's 2n equals 84. I subtract 2n from both sides, so I get 7n. This should have been plus. 7n equals 84. So again, n equals 12. All right. The next one, we have the sum of, this is like the second problem we did. We're going to let the first number, n be the first number, and 44 minus n equal the second number. All right, so we're going to get n over 44 minus n equals 3/8. Now we're going to cross multiply here, and we get 8n equals 3 times 44 minus n, and we're going to simplify this, and we get 8n equals 132 minus 3n. Add 3n to both sides, you get 11n equals 132. So n equals 12. A lot of n equals 12s on these. The next ones are going to get a little harder because we're going to have to, we're going to get quadratic equations. So the next one is the sum of the reciprocals of two positive even integers is 5/12. Okay, so what we're going to do is I'm going to let n equal the first positive even integer. So just the first. And I'm going to do n plus 2 equals the second. Because if n is 2, then the next number would be 4. So you keep adding 2's. And we want the sum of the reciprocals. So the reciprocal of n is 1 over n. And the reciprocal of the second number is 1 over n plus 2. And it equals 5/12. All right, so here we're going to find the common denominator. And our LCD is going to be 12n times n plus 2. We have to take each piece here because they're all different. I'm going to multiply it. I'm going to just do it all together here. Times 12n times n plus 2. Now, I'm going to, on this one, I'm going to cancel the n's here. So 1 times that is just 12 times n plus 2. Now, when I distribute, what cancels is this part. So I just get 12n. So that gives you 12n. And on the third part, the 12's cancel, and I just get n times n plus 2. Now I clean all this up, simplify. Now this equals 24n. Since this is n squared, I'm going to move everything to the right here. Get n squared minus 24n. Well, actually, it's minus what? 22n. I'm actually subtracting 24n from both sides. And minus 24 equals 0. I went ahead and just combined this mentally. That was 24n. I subtracted it. Okay, now we're going to factor. And when you factor this, well, actually I had a 5 here, so this should have been a 5. Put a 5 there. I don't want to start this video over, so now I forgot to multiply by 5 here. Okay, now when I factor, I'm going to get 5n plus 4 and n minus 6. And that gives me that back. Well, we want the sum of even, positive even. So this one right here is negative 4/5. We have to disregard this one. And here we have n equals 6. So that means my first number is 6. Therefore, my second number is going to be 8. And that would be your answer. Okay, the next problem is the sum of a number and its reciprocal is 25 over 12. So the first number is n, and its reciprocal is 1 over n, and that equals 25 over 12. So basically my common denominator is 12n, my LCD is 12n, and I multiply each piece by 12n. And so you're going to get 12n squared plus 12 equals 25n. Now since we have the square here, we have to factor. So I'm going to move everything over and put it in standard form for a quadratic. Going to factor, and when I factor this, I get 4n minus 3 times 3n minus 4 equals 0. So my solutions are 3/4 or 4/3. And you can see these are reciprocals to each other. Okay. The sum of two numbers is 12. The sum of the reciprocals is 12 over 35. Is this the last one? And this one I'm going to show you a trick. All right. I know the sum of two numbers is 12. There's the sum of the reciprocals. So this would be, the first number is 12. And the second number, so this is the first. I know the second is going to be 12 minus n, like we did on the previous one. So we're going to do the reciprocals. And you could have done this on previous problems, but instead of doing all this factoring and all this, and this turns out to be really big, I'm just going to ask you what two numbers, because if I'll show you in a minute, that you multiply by give you 35, but when you add them, you get 12. The answer is 7 and 5. So if I let my numbers be 7 and 5, then 7 plus 5 is your 12, and 7 times 5 is your 35. So let me just clean this up. So it'll be 12 minus n plus n over n times 12 minus n equals 12 over 35. And you can plug it in that way, so you get 12, which matches here, over 12n minus n squared. So when they're asking you something like this, and they're talking about the sum of the reciprocals, if you do something like this, it makes it a little easier. You can kind of see the pattern. If we go back, we could see the pattern here. Well, this one you couldn't see the pattern. And this one, we want, let's see if we can get another one. Well, that's all. So anyway, I hope you enjoy and have a nice day. The next video is going to be over setting up proportions. Thanks and have a nice day.